Hello, I'm Doug Burks, and I started a little project in 2008 called Security Onion, and it's my privilege to join you today. I appreciate the invitation and the opportunity to be here. So we're going to talk a little bit about how you can peel back the layers of your enterprise with this free and open source platform called Security Onion, and specifically our new version, Security Onion 2. Let's first talk about the bicycle. So I want you to close your eyes and I want you to think about your very first bicycle. That may have been a little 12-inch bike with training wheels, could have been a 20-inch BMX bike, but I want you to think about that feeling of when you learned to ride a bike, you figured out how to balance, and you could all of a sudden go much faster than you could have gone before. You know, as a kid, you kind of thought you could run fast, but when you hopped on a bicycle, all of a sudden you could run a whole lot faster. And then maybe at some point later in life, you upgraded to a 10-speed bike or maybe a mountain bike with many more speeds than that. And you felt the advantage of having all of those gears and that additional climbing power and that additional acceleration. So what does this have to do with computers or computer security or anything like that? We'll get to that in a minute. But I like the idea of the bicycle as a really great analogy. And the folks at Scientific American, way back in 1973, they did a story on the bicycle. And as you can see from this graph, they took a whole lot of data and they charted it out. And they kind of compared different animal species and how efficient they are in terms of moving themselves around compared to their actual weight. So if you look up here, you know, mice are pretty inefficient. Hummingbirds get a little bit more efficient. You know, dogs are pretty efficient. And then man is okay, you know, down here, but still we as human beings, we're still beat out by horses, and salmon of all things are incredibly efficient animals. But the folks at Scientific American had the brilliance to calculate the data for man on a bicycle. And you can see here that this is an extremely efficient mode of transportation, more efficient than man on his own, more efficient than even jet fighters or automobiles or other form of jet transport. So this is pretty interesting, this concept of a bicycle enabling mankind to go further and to go faster and to be more efficient. And so, again, I really think this is a great analogy. And somebody else thought it was a great analogy too, and that was Steve Jobs way back in 1980. When he said, when we invented the personal computer, we created a new kind of bicycle, a new man-machine partnership. And so they created this ad campaign where they basically said that, you know, an Apple computer is like a bicycle for the mind. And, you know, I really like this idea of a computer taking your ideas further and faster than you could take them on your own. And so you kind of see their ad campaign here where, you know, you see a guy on a bicycle and you see the Apple computer in the back. And this logo for that particular ad campaign actually reminds me a lot of our new logo for Security Onion Solutions. You know, you can kind of see, of course, the onion in the middle there also kind of looks like you're pedaling those bicycle pedals and you're going further and going faster. And so our idea here is that we want to build a bicycle for blue teamers. We want to equip defenders to go further, to go faster, to chase down those adversaries that are already in their environment and interrupt them before they achieve their objectives and kick them out of the environment. So that's kind of our goal with Security Onion 2 especially, is to move further, move faster, make you more efficient, give you more data at your fingertips so that you can chase down those adversaries in your environment. So a brief history of Security Onion. I started Security Onion way back in 2008. And the idea was that, you know, we as defenders already have a lot of disadvantages. Our adversaries have a lot of advantages over us. It's very easy for them. And one of the advantages that, I noticed way back in the day was, one of the first major security incidents I worked, I could tell very early on in the investigation that the attacker was using Backtrack Linux, which is now called Kali Linux, of course. And so, that's one of the advantages that adversaries had at the time. They had all of their favorite tools already compiled, already configured, and ready to go in an easy to use platform, so that they didn't have to be Unix grandmasters just in order to compile their tools and get their tools up and running. And so really, to me, it was fundamentally unjust that we as defenders didn't have the equivalent of that. And so I set out in 2008 to try to rebalance that equation, to start building that free and open source bicycle for blue teamers. So I started building it in 2008, released the first version in 2009. And over the years, we continually updated that free and open source platform, originally based on Ubuntu. And so we kept track of Ubuntu releases throughout the years and continually added new components and replaced older components, and responded to the needs of the open source defender community. What is it that you find as a problem or a pain point? And let's see if we can solve that with some additional open source components or some additional integrations here or there. And so ultimately in 2018, we kind of reached a point where we said, okay, we've taken this existing platform about as far as we can take it. Now it's time to start thinking about the future and what the ideal platform might look like using today's technologies. And so in 2018, we started working on Security Onion 2. We kind of codenamed it as Hybrid Hunter. You may have heard it being called that if you were kind of following along with some of that development work. But we worked on that, for a couple of years. In 2019, we reached the alpha release. And just 1 month ago, we released Security Onion 2 at our annual Security Onion conference. So let's talk a little bit about what that actually looks like. First of all, it's a major effort, over 5,000 commits. If you go out to our GitHub repo, you can see all of the effort, all of the blood, sweat, and tears that went into that new platform, starting in 2018, going through 2019 and through 2020. So it was a significant effort to build this platform and to get all of the components working just right to ultimately help you monitor your network traffic and collect those logs, and do so in a very efficient manner. So let's talk about some more numbers. As with any good software project, we believe in release early, release often, which means that, as we would develop this new platform, we would do periodic releases. So we did 4 technology preview releases, 4 alpha releases. Then we moved into the beta phase and we did 3 beta releases. Then we moved into the release candidate phase. And so we did RC1, RC2, and RC3. All told, this project took us over 34 months. And so it's a significant labor of love. And so in terms of total ISO image downloads, we're now over 1.5 million downloads. And that's total ISOs. So that's the previous Security Onion platform plus Security Onion 2. But that's just kind of goes to show the worldwide community that has formed around this free and open source project. So how do you install Security Onion? Well, I mentioned the ISO image, and that's the absolute easiest way to install Security Onion. So if you download our Security Onion 2 ISO image, it is based on CentOS 7, and we have automated that installation process. So it figures out all the partitioning for you and does it automatically. And so that's the easiest way to get up and running with Security Onion 2. Now, if you don't want to use our ISO image, you don't have to. You can install standard CentOS 7 or Ubuntu 18.04 and then run our installer on top of it. So because we built this new platform using Docker containers, that means then that we can support multiple Linux distributions. That's why we can support both CentOS 7 and Ubuntu 18.04 at the same time. Those Docker containers are orchestrated using SaltStack, and really the entire platform is kind of configured as a series of SaltStack states. So it's going to configure your system for you and make sure that those states are maintained. And that creates a system that's more resilient than our previous generation of Security Onion. So once you've got it installed, how do you actually make your adversaries cry using Security Onion? Here's our architecture diagram that you can find in our documentation. And what you'll see here is kind of your typical standard enterprise network where you've got the big bad internet, you've got an adversary out here, he wants to get into your network. We've got our enterprise firewall sitting here. And so what we want to do with Security Onion is to first monitor your network traffic. And the first place to start monitoring that network traffic is right inside of that network firewall, where we can gather that north-south traffic of traffic that's leaving your network and going out to the big bad internet. Now, in addition to that, we'd also like to monitor for lateral movements. So we want to monitor for that east-west traffic as well. So what we can do is we can insert taps, or we can configure span ports to collect that network traffic and send it to Security Onion to a sniffing interface on that Security Onion instance. And then, as we all know, more and more of our network traffic is encrypted these days, and that's generally a good thing for privacy concerns. However, for us as analysts and defenders, that makes our jobs a little bit more difficult. It creates some blind spots for us. And so therefore, we like to fill in those blind spots with some additional endpoint visibility. So you see this diagram depicting that we're collecting logs from our servers, from our workstations and laptops. And we have several different means of doing that so that we can integrate with whatever you choose as kind of your best of breed endpoint agent. But that's kind of a picture of how Security Onion is going to integrate into your environment, monitor your network traffic, and collect your endpoint logs as well. Bring all that back to a single central location where you can slice and dice that information and hunt down those adversaries in your environment. So let's talk about network visibility. And so when we're collecting traffic from that tap or span port, the first thing that we're going to do is we're going to monitor and analyze that network traffic using Suricata. And so by default, that's going to generate network-based IDS alerts. So it has a series of rules. If those rules match against your traffic, then that generates alerts. Now, as we all know, more and more sophisticated adversaries these days are able to evade our IDS signatures, just like they're able to evade our traditional antivirus signatures. And so it's very important for us to be able to have additional context so that we can do threat hunting effectively. And so we generate protocol metadata using either Suricata or Zeek. Again, these are both open source components. They do a great job of analyzing your network traffic and giving you logs to show you, for example, all of the DNS lookups on your network, all of the HTTP transactions on your network, or all of the SSL certificates flying across your network. In addition to that, we also do full packet capture, and this is provided by Google Stenographer. And so the idea here is that an IDS alert coming from Suricata, that might be a starting point for your investigation. And an analogy we like to use is, for physical security for your house, you may want a security system And so if they come and install a motion activated camera that takes a snapshot, well, that's limited value in terms of trying to reconstruct the scene of the crime. If you had an attacker actually break into your house, you wouldn't know if they had stolen certain items or not, because you don't have all of the evidence. So what we prefer to have is a video camera that's recording all of that activity from start to finish. And that's exactly what we have in full packet capture. That's exactly what Google Stenographer is providing for us. So that means then that we can start with an IDS alert. That's kind of a starting point for our investigation. We can start to add some context around that IDS alert using that protocol metadata. And then if we see something that's really interesting, if we find a particular TCP stream, for example, that looks like it might be command and control activity or maybe data exfiltration, we can drill into that, go and retrieve that full packet capture, and fully reconstruct the scene of the crime. And that's very powerful. So this is what that looks like kind of from an architecture perspective. So if you connect that tap or span port to the sniffing interface in Security Onion, then AF Packet in the Linux kernel is going to act as a flow-based load balancer and enable you to spin up multiple instances or multiple workers for Stenographer, Suricata, and Zeek in order to be able to handle high amounts of traffic. And then those processes are then analyzing the traffic, recording the traffic, writing it out to the file system, where we can then pick up that information, and depending on what type of data it is, we can do things with it. For example, we can have FileBeat pick up our Suricata logs and our Zeek logs and send those into the Elastic Stack, where we can then slice and dice those logs. Next, let's look at endpoint visibility. As I mentioned before, more and more of our network traffic is encrypted. That's generally a good thing when security is concerned, but it does mean that we might need to work a little bit harder as analysts or defenders to fill in those blind spots. So we do have a few different options here for how we might gather some additional endpoint visibility. The first of which is OS Query. OS Query is a great cross-platform utility that gives you the capability of not only collecting logs from your endpoints, but also allows you to query those endpoints dynamically in real time. So you could actually run a query against your entire fleet of OS Query endpoints, looking for things like processes running or scheduled tasks, maybe looking for specific persistence mechanisms or things like that. So it's a really, really great utility that, again, is cross-platform. Another option is the Elastic Beats family of endpoint agents. Again, these are free cross-platform agents that can be installed on many different platforms across your enterprise. They can collect the logs off of those endpoints and send them back to the Elastic Stack that's built right into Security Onion. Next, we have Wazoo, which is kind of the next generation fork of an older platform called OSEC, which is a host-based intrusion detection system. The nice thing about Wazoo is that it gives you not only log collection, but log analysis, encrypted log transport, file integrity checking, and rootkit detection. Now, if you are a Windows shop, as many enterprises are, you tend to have lots of Windows endpoints in your organization. There's other things that we can integrate with to give you even better visibility into those endpoints. For example, Sysmon. Sysmon's a great utility from the sysinternals team at Microsoft, which gives you really comprehensive logging for things like process creation, process termination, registry changes, and network connections, and so on and so forth. And so you can install Sysmon, you can configure it, and you can then collect those Sysmon logs using any of those above transport mechanisms that we talked about. And then we have parsing built into Security Onion to understand those Sysmon logs and to help you get the most out of them. We also have integration with AutoRuns, which is another great free utility from Microsoft, which gives you the capability to look for persistence mechanisms across your Windows endpoints. So that's another great thing that we've done over the years to enhance our endpoint visibility. So now that you kind of have an understanding of how we're collecting information into Security Onion, both from the network side and the host side, what then? What do you actually do then to go and view that data? Well, you're going to log into Security Onion, into what we now call the Security Onion console. And that Security Onion console, or SOC, is then going to give you access to several different analyst interfaces. Some of these we've developed ourselves. Some of these were existing open source components that we integrated quite heavily into Security Onion. We'll talk about each of these in turn. So the first is our new alerts interface. We're very proud of this new alerts interface because we worked really hard to come up with the simplest and most efficient method of dealing with your network-based IDS alerts, your host-based IDS alerts, and any other alerts that may come into Security Onion that you as an analyst may need to be able to look at those alerts, slice them and dice them, and be able to go into your investigation in multiple directions to kind of surround those alerts with additional context to guide your investigation and ultimately get to a point where you can either say that this is a false positive, or maybe it's a true positive, but I just don't care about it. Or maybe it is a true positive and I do care about it, so I do want to engage the incident response process. And so we really tried to build something by analysts for analysts, to make a custom alerts interface that really got out of your way and enabled you to be efficient. The way that we talked about the bicycle is going to help you to shift gears and to work harder and to go faster than you ever could before. So we're very happy about this new alerts interface, and it's going to give you several other capabilities as well in terms of being able to pivot to other interfaces that might give you additional information, such as our new hunt interface. And this web interface is something that we designed specifically for threat hunting, with the intention that modern adversaries, and particularly sophisticated adversaries, are able to evade our IDS signatures, meaning that we might not have any alerts in that alerts interface to help us find these sophisticated adversaries. And so in order to hunt them down, we're going to have to go on some threat hunting expeditions. And that's really what this new hunt interface was designed to do. So it allows you to take a very expansive look across your entire body of logs that you're collecting, both from the network and from the host side, and be able to do group buys, to do stacking, to do data expansion, data reduction, all of those things that you might typically do on a threat hunting expedition as you're taking thousands or millions or billions of logs and trying to group that down or collapse that down into something that's a little bit more manageable. And as you're aggregating on various different fields, that helps you to look for statistical anomalies, helps you to find those outliers in your environment that might be indicative of those adversaries that are hiding out in a dark corner somewhere. And so again, we tried to make the simplest, most efficient interface for doing this kind of threat hunting work that we would want to see if we were the threat hunters in your environment. So again, we're very proud of our threat hunting interface. We also built a new PCAP interface as well. And so we talked before about having full packet capture being recorded by Google Stenographer. But once you've kind of maybe started with alerts or maybe started with a hunting expedition and you found a particular TCP stream that's of interest, maybe that's command and control, maybe that's data exfiltration. that's when we pivot into our PCAP interface, and we can see kind of an overview of the packets in that stream. We can switch to an ASCII transcript. You see an example of that here on the right. And that enables us to see exactly what happened from start to finish. We can then reconstruct the scene of the crime, as it were. Now, in addition to those three interfaces that we built ourselves specifically for Security Onion, we've integrated some other components as well. So if you are familiar with the Elastic Stack, you're familiar with Kibana as the web interface for Elasticsearch. And so we've integrated Kibana as well, including lots and lots of pre-built dashboards right out of the box. So we have at least one dashboard for every single one of the major data types that we include in Security Onion. So again, really trying to help you to build a platform as quickly as possible without you having to be a Unix grand wizard to put all of these tools together. Let's just have everything already compiled and configured, ready to go at a minute's notice so that you can focus on the real work of incident response. In addition to Kibana, we leverage several other open source utilities as well. One of those is CyberChef. CyberChef is a great web interface for analysis work and for taking data and decoding it and massaging it and trying to figure out what that data actually represents. And so we include that right in Security Onion as well. Another thing that we worked quite heavily on for Security Onion 2 is what we call Playbook. And the idea here is that there's a great open source community called Sigma. And what they do is they write rules to look for signs of interesting activity across different data sets. What does that actually mean? Well, you can take a Sigma rule and you can run it across an Elasticsearch index, or you can run it against a Splunk instance. There's several different converters for different backend systems. And what that means is that we can really take advantage of all of the wealth of information that's out there from this Sigma community in terms of threat hunting and things that other incident responders are seeing out there. We can now leverage, even if we're not using Splunk, we can convert those Sigma rules to an Elasticsearch backend, run them across our Elasticsearch instance, and we can instantly get alerts based on those rules firing in our environment. And so Playbook is a great way to consume those Sigma rules and to go through there and enable those Sigma rules that you might want to run on a regular basis, and also write your own Sigma rules that are then going to be scheduled on a periodic basis and then firing alerts that would appear in that alerts interface that we talked about earlier. Next up, we have Fleet. Fleet is a nice web front end for managing OS Query endpoint agents. We talked about OS Query before, how it's a cross-platform agent for not only collecting logs, but also enabling you to run queries against those agents. And so Fleet is what enables you to do that very quickly and easily. We also have the Hive, and we're using the Hive for incident management, meaning that if you have some alerts that are interesting, you can escalate from alerts directly to the Hive. If you are doing some threat hunting in our Hunt web interface and you find something that's interesting, you can escalate directly from there to the Hive, and you can create a case, and then you and your fellow team members in the Security Operations Center now have one place to work through all of these cases where you can collect your indicators of compromise, any other observables that might be associated with that particular case. And all of this is really pushing you to, at some point, close that case, and then you'll have that case and all of its indicators, all of its additional information, so that you can refer back to it in the future if necessary. We also have the Attack Navigator from the fine folks at MITRE. And this really kind of gives you a nice overview of what kind of coverage you have for the MITRE attack framework. This also integrates with Playbook, the thing that we discussed just a couple of slides ago, so that as you add more coverage in Playbook, it will actually add layers to Attack Navigator to show you that you have that additional coverage. We also have Grafana, and Grafana is a great way for monitoring the health of your Security Onion deployment. So you can check and see how your system is doing, how the processes are doing, how much PCAP retention you have, how much log retention you have. And all of these Grafana dashboards are already built for you right out of the box. Again, helping you to get up and running as quickly as possible so that you can focus on the real job of finding those adversaries and kicking them out of your environment. We also have something we call the Analyst Workstation. And the idea here is that if you're going to be doing this kind of analysis work, chances are at some point you're going to find an interesting alert, or maybe in the process of threat hunting, you find some interesting network traffic where, say, a Windows exe was transferred. And so maybe you want to carve that Windows exe out and maybe do some file analysis, maybe do some reverse engineering. But what you don't want to do is run that Windows exe, obviously, on your corporate Windows image, because now you're taking a bad day and you're making it even a worse day. So we'd rather do that kind of analysis work in a relatively safe virtual machine environment. And that's what our Analyst Workstation is designed for. So we have a program that when you run it, it installs all of these Analyst Workstation tools, including a full GNOME desktop, the Chromium web browser, Network Miner, which is a great PCAP analysis utility, and of course everybody's favorite Wireshark, and lots of other PCAP utilities. And so this gives you this virtual machine environment that can enable you to do some of that kind of analysis work in a more safe way than if you were to try to do it on your corporate Windows image. I mentioned Network Miner, and this is a great utility. Again, free open source utility for analyzing PCAPs. It does file extraction and lots of cool things bundled into Network Miner there. So now let's talk about the power of community. I mentioned before network-based IDS rules. Those come from the Emerging Threats Project. In addition to that, I also mentioned Wazoo, which is a host-based intrusion detection system. So we've got NIDS rules and HIDS rules, and the communities behind those rules have lots of years of experience kind of built into those rule sets. In addition to that, I also mentioned Sigma rules. So there's lots of intelligence in that community as well. Yara rules, we're importing those and leveraging those quite heavily as well. We're also integrating with Elastic Common Schema. So we did a lot of work in Security Onion 2 to make sure that our Elastic indices were leveraging Elastic Common Schema to make it easier for you to integrate with other tool sets, integrate with other techniques, and ultimately leverage other communities. One final thing here is Community ID, and this is a really great way for us to correlate different types of logs. You know, we talked about Suricata alerts and Zeek logs and Sysmon logs and all these different log types. But if you're having to manually correlate from, say, a Suricata alert to a Zeek log and to other log types, that's a lot of manual work that, quite frankly, most incident responders don't have time for. So it would be better if we leveraged this computer as a bicycle theme to really let the computer do the work for us. And so in Security Onion 2, we enable the native community ID support in Suricata. So you can see some examples of that there. So this is the community ID string that represents that particular TCP stream. Zeek also supports community ID support, and we turn that on by default as well. So you can see some examples of that here. Now, in addition to that, we sponsored the development of community ID support in OS Query. Again, OS Query is open source. We worked with one of the primary developers and added that community ID support so that if you have the community ID value of an interesting piece of network traffic, you can actually query via OS Query, and you can determine the actual process that generated that traffic. And so you can see in this example where we had some traffic that was interesting, and we sent that query into OS Query, and we determined then that that traffic came from Netcat connecting to osquery.io on port 443. That's tremendously powerful to be able to walk that back to the actual process that generated the traffic. But now what about those tools where we can't easily add native community ID support? A great example is Sysmon. So if you go to the GitHub repo for Sysmon or for sysinternals, this has been requested as a feature for them to add community ID support. They've added this to their backlog, but there's no ETA for that. We don't know if or when that will actually happen. And it's not open source, so we can't submit a pull request ourselves. And so what do? Well, here's what we did. We sponsored the development of an ingest processor for Elasticsearch to automatically generate community ID for any log that has the necessary information, meaning protocol, source IP, source port, destination IP, and destination port. And so as that log is coming in, we can optionally generate that community ID value on the fly. And you'll actually see this in just a minute in the demo. So let's talk about some use cases. So if you are new to Security Onion, and especially for Security Onion 2, you might want to start off with just a small forensics VM just to kind of get your feet wet with how Security Onion works. And so you can run what we call import node, and that's really designed for importing a PCAP file. And so you can do that in a minimal amount of RAM in just a few minutes. It's really quick and easy. It's a great way to get started with Security Onion. Moving from there, you might want to stand up your first production deployment, and you might do that in a single standalone box where you have one Security Onion installation that's doing your network collection and analysis. It's also collecting logs from your endpoints and doing everything on one box. And that works okay for small networks. But if you're really standing this up for a large enterprise network, you probably want to go to a distributed model. And so that's where you're going to have a manager that's going to manage your entire deployment. You're going to have multiple forward nodes that act as sensors, network sensors, and all those logs are going to get sent to your manager. And then search nodes are going to store those logs and allow you to search across those logs. And so this becomes really kind of a very scalable architecture where if you need additional capacity, you can simply snap in additional nodes. So looking at each of those different use cases, here's the small forensics VM. We've got this small standalone thing that's running a minimal amount of processes. We move from that to the standalone deployment. You see, again, it's a single standalone box, but it's running more processes. It's capable of doing more things. It's capable of handling higher loads, but it's still just a single standalone instance. Moving from there to a full distributed deployment, this is where things get really interesting, where you have your manager here that's managing your entire grid. You have one or more forward nodes that are collecting network traffic, analyzing it, and then full packet capture remains on those forward nodes, whereas the rest of the logs get sent to the manager, where they're then stored in the search nodes. And when you log into our alerts interface or our hunt interface, you're then searching across all of those search nodes. Again, this is a very scalable architecture. So if you need to add additional nodes, you can simply snap those in. Now, with a new platform comes new documentation, so you can go to docs.securityonion.net, and you'll find that we've reworked all of our documentation for Security Onion 2. This also includes a brand new cheat sheet, So if you want a handy dandy desk reference, you can print out the cheat sheet, have it right there, and that gives you a quick reference to most of the major commands that you'll run from the command line, and links, pointers to other sources of information as well. You can find all of this, the documentation, the cheat sheet, some free YouTube training as well on our website at securityonion.net. And if you get stuck and have a problem, we've actually got a brand new GitHub discussions site. So you can go to securityonion.net/discuss, and you can post your questions or problems there. And a member of our community will respond to you, usually pretty quickly, and help you out with whatever questions or problems you have. Now, in the last few minutes here of our presentation, I would like to show a very quick case study, again, kind of referring back to the architecture diagram that we started with at the beginning. We've got a Security Onion installation that's monitoring our network traffic. It's also collecting logs from a Windows box, and I'm also collecting logs from my firewall as well. And so the point of this case study is to kind of highlight and showcase not only network visibility and host-based visibility, but using community ID, as we talked about a couple of slides ago, to correlate all of that activity together. So now if I pivot over to my demo machine, here you can see this is Security Onion 2. I'm already logged into Security Onion console, and we're looking at the alerts page. So here you can see all of our network-based IDS alerts came from Suricata as it was monitoring our network traffic. And you can see that all of these alerts are kind of correlated together using community ID. And so, for example, you might look through here for interesting Suricata rule names. For example, here's some alerts that have to do with executables. And if you look at the community ID value, this community ID value is actually identical. And so what that means is that all 4 of these IDS alerts are actually for the same exact TCP stream. And you can see that if you look at the port numbers here, this is 49812, and that's identical even in this one where the port numbers are reversed because we're looking at a different side or a different direction of the traffic. So now when we're doing our alert triage, we might want to cast a wider net and see if there's any other information that we have about that particular stream. And the community ID value is a great way to do that. So if I click on that and then click the magnifying glass, that's going to take me to Hunt. And that's going to give me a query that's going to hunt for that particular community ID value and then group it by event module and event data set. So what this tells me is that I have not only the 4 alerts that I saw in alerts previously, but I also have some Zeek logs, and I've also got a firewall log, and I've also got a Sysmon log. All of these are correlated together just based on that community ID value. And so this really kind of quickly shows you that the value of community ID in really giving you a 360-degree view of what's happening in your enterprise, because we can instantly get not only the network picture, not only the firewall picture, but also the host picture as well. So for example, if I were to drill into this, I could actually see the process that generated that network traffic. And that's amazing to have that kind of capability that quickly and easily. Another thing that we might want to do is if we go back, we might want to go to full packet capture. And so if I click this icon, that's going to take me to my full packet capture. So here I can actually see calc.exe. I can see the web server's response. I can see the MZ file header. And so again, it's amazing to have that kind of capability at your fingertips to have all these different data types correlated using community ID to be able to pivot to full packet capture and do all of that very quickly and easily. So that's a very brief case study. You can find more information at our website, securityonion.net. We've got documentation. We've got a free YouTube playlist based on Security Onion 2. And so you can head out to those websites there for more information. And we'd love for you to download Security Onion 2 and try it out. We hope that it helps you to peel back the layers of your enterprise and make your adversaries cry.